Dr. Astrid Anker.
Have you ever tried listening to a quiet conversation at a crowded party, but no matter how hard you try, the surrounding noise makes it almost impossible to catch the details? Particle physicists had the same challenge, separating a signal from different kinds of noise to find answers to some of the biggest open questions in physics, such as, why does our universe have more matter than antimatter? nEXO is an international collaboration that's trying to answer this important question by measuring a theorized rare decay process called neutrinoless double beta decay, which I don't expect anyone here to remember, but the challenge is making sure when this rare needle in a haystack event occurs, we can measure it. Unfortunately, that haystack is radioactive. Everything around us, including the materials used to build our experiment, contain tiny amounts of radioactivity. In particular, the radioactive element radon can hinder our ability to see this rare signal. And that's why everything used to build our detector must be screened for radon. At the SLAC National Accelerator Lab, we have some of the most sensitive radon counters in the world. My research is focused on using these counters to measure samples. How this process works is you enclose a sample in a chamber long enough that it emits radon, and then measure the gas in that chamber with very sensitive and specialized equipment to determine how much radon was emitted. Our current instruments are sensitive enough to measure as low as 1 radon atom per day. Now, as a frame of reference, there are over 10,000 radon atoms in a single breath of air. We think we can do better, though, so I'm also developing these counters to be more sensitive. Classifying the amount of radon in materials doesn't just help our experiment. It also guides future experiments on the best low radon emitting materials. We share our measurements in a materials database, which ensures that time is saved and material not wasted when building the next generation of detectors. Without work to reduce radon, our detector would, in a sense, be stuck in that noisy party, unable to hear the cool new physics trying to be heard, but by quieting that noise, we can finally listen.